Here's what most people don't know. Many parts of the world are within 60 harvests of running out of useful topsoil. 60 harvests, not years, harvest. So what does that actually mean? Is there really a countdown happening beneath our feet? And if that imbalance is real, how close is it to where you live? I'm Dennis Lisak, and this is Tomorrow Explained. On this channel, I break down the systems we assume will always work until they don't. Let's talk about something almost invisible, soil, because civilization doesn't grow from the ground up. It grows from 6 inches down. Globally, most of our food grows in a thin layer of topsoil that averages less than a foot deep. In many places, it's much thinner. That narrow biological layer supports roughly 95% of the food we eat. Wheat, corn, soy, rice, vegetables, livestock feed, almost everything on your plate traces back to it. Now here's the uncomfortable arithmetic. Nature builds topsoil extremely slowly. In healthy conditions, it can take 500 to 1,000 years to build just 1 inch. Under modern agriculture, we can lose that inch in less than 10 years. That's the imbalance, that's the tension. Globally, we lose an estimated 24 billion tons of fertile soil every year to erosion. But here's the clearer way to understand it. Soil is like a savings account. Nature deposits about 1% per year. We are withdrawing at 10% every single year. You don't go bankrupt overnight. You go bankrupt slowly. And then suddenly, in many major agricultural regions, soil erosion is happening 10 to 100 times faster than natural formation. That's not background loss. That's structural deficit. Now let's make this real. In the United States, roughly half of the original topsoil present in the 1800s has already been lost. In parts of Iowa and the broader Midwest, erosion rates consistently exceed soil formation rates by more than 10 times. But here's where it becomes layered. Beneath much of the Midwest sits the Ogallala Aquifer. It's one of the largest underground freshwater reserves in the world. It stretches across 8 states, and it has powered American agriculture for decades. Corn, wheat, beef production. The Ogallala allowed farmers to turn semi-arid land into one of the most productive agricultural zones on Earth. But here's the problem. The Ogallala refills extremely slowly. In some regions, it is effectively fossil water, meaning it accumulated over thousands of years. And in many areas, it is being pumped far faster than it replenishes. Some parts of the aquifer have already seen water levels drop by more than 100 feet. So now layer the systems, topsoil thinning, groundwater declining. Healthy soil holds water like a sponge. Degraded soil sheds water like pavement. So when you lose soil, you rely more heavily on irrigation. When you pump more irrigation, you drain aquifers faster. When aquifers decline, farming becomes more fragile. That's not a single failure. That's compounding constraint. Now zoom out. We are feeding roughly 8 billion people today. By 2050, we're projected to approach 10 billion. That means significantly more food production from the same land, from the same thin layer of soil, from the same groundwater reserves. And here's the uncomfortable question. If we are already withdrawing soil and water faster than they regenerate, what happens when demand increases? We compensate, we add fertilizer, we drill deeper wells, we use larger machinery, but fertilizer isn't soil, and deeper wells don't refill aquifers. They delay the problem. Now let's return to the headline claim. Do we really only have 60 harvests left? Not everywhere, not on a synchronized global clock. But here's what that warning actually means. Roughly 1/3 of the world's soils are already moderately to highly degraded. In some regions, productivity is being sustained only through heavy inputs, fertilizer, irrigation, mechanization. In other regions, yields are already under pressure. In sub-Saharan Africa, nutrient depletion limits agricultural growth today. In northern China, severe erosion once fueled dust storms so intense they affected cities thousands of miles away. In the American Midwest, soil loss and aquifer depletion are happening at the same time. So the better question isn't whether the entire world has 60 harvests left. The better question is, how many regions are already running a soil deficit? Because soil doesn't disappear all at once, it degrades. And degradation spreads pressure through other systems. Water retention declines, flooding increases, drought intensifies, food prices fluctuate. History shows this pattern. Civilizations don't collapse because they run out of intelligence. They collapse because they overshoot biological limits. Mesopotamia experienced salinization from irrigation. Parts of the Roman Empire exhausted farmland. Agricultural systems weakened before political systems did. And we like to believe we're immune because we have technology. But technology still depends on biology, and biology still depends on soil. 6 inches of it. So here's the arithmetic: 8 billion people, soon 10 billion, demand rising, soil regenerating at geological speed, groundwater refilling slowly, extraction happening at industrial speed. That's not ideology, that's rate mismatch, and rate mismatch eventually resolves itself. Either we adjust extraction or nature adjusts output. So maybe the real tension isn't a countdown. Maybe it's this: are we rebuilding soil fast enough to keep up with the scale of modern demand? Because foundations don't fail dramatically. They weaken quietly, field by field, season by season, until one year the system produces just a little less than it used to, and then a little less again. And if you want to understand the physical constraints shaping our future, food, water, energy, infrastructure, subscribe to Tomorrow Explained. I'm Dennis Lissock, and I'll see you in the next one.